In this video, I'll show you how to use the quadratic formula to find the roots. The question reads, find the roots of the following equation. The first thing that I notice when I look at this quadratic equation is that it's not in standard form. To use the quadratic formula, it's nice to put your equation in standard form, which looks like this, where you have y is equal to x squared plus bx plus c. To put this equation in this format, we have to bring all of the terms to one side. So I'll take this term over and this term over, where I end up with 5.2x plus 5.1. These two terms haven't changed. This one was positive and this one was positive. They become negative. Minus 1.56x squared minus 2.55 is equal to 0. Next, I'll collect like terms, combining these two using my calculator. 5.1 minus 2.55 gives me positive 2.55. So instead of writing these two terms on their own, I'll write down 2.55 instead. Notice that our quadratic is starting to look like the one we have here. The only difference is that we need to move this term to the front and this term becomes second, where we end up with negative 1.56x squared plus 5.2x plus 2.55 is equal to 0. Notice that when I made this little switch, I didn't change the sign. You only change the sign when you move the term to the other side. Now that I have my equation in standard form, I can easily identify my a, b, and c coefficients. This right here will be my a, this will be my b, and this will be my c. I'm going to write that down. A is equal to negative 1.56, b is equal to 5.2, and c is equal to 2.55. The reason why I document a, b, and c is because I need to substitute these values into this formula, which we call the quadratic formula. And by doing that, you end up with three possibilities. The first possibility is one solution, the other possibility is two solutions, and the last possibility are no solutions. Let's plug these numbers in and see what we get. So we have x is equal to negative, and our b is positive, 5.2 plus minus the square root of b squared, 5.2 squared. And it's always nice to substitute your numbers in brackets. Minus 4 bracket negative 1.56 times c, 2.55. All over 2 times negative 1.56. Now, if this part right here, known as the discriminant, generates a number that is equal to 0, you have one solution. If this part generates a number that is greater than 0, you end up with two solutions. And if it's less than 0, you have no solutions. And what that means is that the curve will never pass the x-axis. Let's see what happens. Negative 5.2, negative times 5.2 is this, plus minus, using our calculator, bracket 5.2 squared minus 4 bracket negative 1.56 bracket 2.55, and we end up with the number 42.952. 42.952. Notice that this number right here is greater than 0, so you should expect two solutions. All over 2 times negative 1.56, and we get negative 3.12. Negative 3.12. Next, we have two fates. We have the positive fate and we have the negative fate. Here's what I mean. If you take the positive fate, you end up with negative 5.2 plus, I'm choosing plus, the square root of 42.954 divided by negative 3.12. This gives us negative 0.4339. If I take the negative route, and you have to take both, I end up with negative 5.2 minus the square root of 42.954 divided by negative 3.12, and this gives me 3.7 And this means that we have two solutions. The first one is negative 0.4339, and the other one is 3.7672. Since all quadratic equations will produce a parabola when it's graphed, our parabola in particular will pass through the point negative 0.4439, so a point over here, and a point to the right at 3.7672. And one more interesting fact, given that our particular quadratic is negative, it will point down if you find the vertex. And so there you have it. That is how to use the quadratic formula to find the roots.